Okay, so for this question, they're asking us to make predictions, find the residual, make a residual plot, look for patterns, and if there's no pattern, then we can say it's a good fit. Okay, so what I've done is I've selected the data. Actually, why don't I take the, well, let me just take the, well, I guess I'll do that. Okay, Control C that. I opened up that in a spreadsheet. I'm going to paste in. Oh, beautiful. Okay, so now they're telling us, let me wrap this so you folks can see this. How do I wrap it? Uh, Data wrap? No, I don't think so. I think it's under view. View, no, edit, no, format, wrapping. There we go. Wrap. Now we can see all the words. So now we do the prediction. Now we don't have to do a regression equation. Whoops, they gave it to us. We come back there. They gave it to us. Let me copy this so we can paste. I'll just paste it in the spreadsheet. I might not be able to see it, but I don't have to remember it. Now you can certainly do this on pencil and paper. There's nothing wrong with doing it that way. Um, what I'm trying to do is make it easy. So this equation, which is predicting number of students based on the year, because they told us that it would make sense. The year would be the explanatory variable, the X, and number of students would be the Y. And let's make sure that's what they said. That's important. Let's see. The number of students in a school course is increased since school opened. So X represents the year, Y represents the number of students. So there we go. Okay, so, and it's that 14X plus 17. So we would do this by hand. I would do 14 times 0 plus 17 is what the equation predicts. Notice that's not the number of students. So this is what the regression equation is. It's not going to fit that data exactly. That's why we get the residual. These are the actual data points, right? Yeah. Okay, so this is going to be 2017 because 4 times 0 plus 17 is 17. Then the next one is going to be, so what I'm really doing is I'm doing 14 times 1 plus 17. The next one I'm doing 14 times 2. Well, not 12, Dan. 2 times plus 17. And then 14 times 3 plus 17, so on and so forth. I'm just going to do this with the equation. So equals 14 times that number plus 17. And it'll fill down for us, thank goodness. And there we go. Now to get the residual, remember the residual is the actual number minus the predicted number, right? We talked about that last week. So equals the actual number minus the predicted number. Oh, isn't it smart? And fill down. Okay, so those are the residuals. We got some positive residuals. We got some negative residuals. Now they want us to come back here. So can I do this? Let me do this. Okay, and I'm going to open up, go to that problem. Here we go. So the predicted number of students for year 0 is 17. The residual was 5. It underpredicted. The predicted number is 31. It over-predicted by 5, so we do minus 5. I'm going to do, let's see, the actual predicted number is 45. That's also over-predicted by 5. And then 59, it's exactly 59. That's what the equation predicted, so that's a 0 residual. 78 predicts 73. So in a year 4, the equation predicts 73, and that's a residual of 5, actual minus the predicted, right? And when it's year 5, the equation predicts the 87, so that's 4 too high. Okay, now they want us to make a residual plot. So what you're going to do is you have X on the Y-axis, residuals on the Y-axis. So I'm for year 0, the residual is 5. For year 1, the residual is negative 5. See what I'm doing? For year 2, the residual was negative 5. For year, what is it? 0, 1, 2, 3, 0, 1, 2, 3. Year 3, the residual was 0. For year 4, right? It's year 4, isn't it? Yep, year 4, the residual was 5. And for year 5, the residual was -4. So then we ask ourselves, do we see a pattern? Well, I'm not seeing a curve. I'm not seeing a line. I'm going to say this looks fairly random. Granted, it's only 6 data points, so it's really hard to say. But I'm going to go on a limb and say, does your regression model fit this data? Yes, because the plot has no pattern. Remember, if there's a pattern, that's a problem. It means that your regression model has a bias built into it. Let me see how I did. Taking a risk here. Let's see. It likes all of that. It didn't like something. What were the answers? What did it not like? Oh, did I miss it? Did I miss one? Oh, oh, I see what I did. You see what I did? Right there. Yeah, that's what I did wrong. You probably caught me doing that. And then yes, there's no pattern. So other than me being a dummy and can't plot point portraits, that's how you do this problem. Okay, so hopefully you get a similar question. It's just like this. Remember, look for patterns. If there's a pattern, the residual plot tells us this probably isn't a linear model probably isn't a good model.